Welcome to part 2 of chapter 11. This is fossil fuels, and as most of you know from watching the first part, I made a little error and did not cover slides 7 and 8, so I'm going back to 7 and 8. Then you can do your checking your knowledge. So we're starting with coal today. We'll be looking at, in fossil fuels, at basically 3 different types of fossil fuels. That's coal, oil, and natural gas. So today we're looking at coal. Coal is primarily used for electricity, and it is the least expensive of the fossil fuels to use for electricity because it is in the highest abundance. However, it is very dirty. And now we're seeing a switch from coal to natural gas for electricity purposes. Again, I think I told you in part 1 that South Florida, we use natural gas instead of coal. We don't have any coal reserves close to us, and natural gas is a lot cleaner, so we use it. It's easier to transport to us. Anyway, let's get started with coal. Types of coal. A pre-coal called peat was used. It's very soft, and peat looks almost like it's a rock, striated layers that's soft, and it has a lot of thermal capacity, or BTUs. So used before we had the abilities to dig coal out of the ground. Lignite, this is soft, low heat. So, and then subbituminous coal, also soft, and it has low heat or very little BTUs associated with it, but it still does put off heat. And the heat, when anything's burned, it's the heat that creates the energy. Bituminous coal, this is what we use most often. As you can see, it's the most common. It tends to be high in sulfur, so we call it a dirty coal. And it has to be, in the United States, we have to mitigate release of sulfur, nitrogen, and mercury. But it does have a high temperature and high heat, therefore it does put off pound for pound more BTUs. Anthracite is our highest quality. It's a deep black coal. It is a beautiful looking rock. Almost want to cut it out and wear it as jewelry. It's so pretty. Not a lot of it, but we do have veins up in Pennsylvania. You're going to be reading about this, I think, in an article or out of a book I have that talks about an anthracite subsurface mine. And it's used when they can get to it effectively. But again, bituminous is the most common, so it is the most cost effective. Least cost per BTU. So these are the 4 types of coal plus peat. Where's coal located? The United States, Russia, and China have 50% of coal reserves. And the United States has just about the most. If you look at this, we're right up there with Asia, which would be China. But I want you to notice too, with this, China's been using coal, and so this is from when the book was created, and our reserves are a little higher now than actually China's reserves because we're not using as much coal as they are. Excuse me. So about 200 years and for total coal reserves. The estimates from everything I'm reading is anywhere from 180 years, and that's being very conservative, to 253 years. So I put on here 200 years. 2 types of coal mining. There's subsurface, which is going underground, and surface. Subsurface is not as much of an environmental issue as surface. Subsurface, they dig a tunnel underground and they mine the coal from underneath. Basically, you have a hole that the coal comes out of, and it's usually a big hole. It's a huge cave because they have huge machinery that goes in there now. But what we see, subsurface mining is very, very dangerous to the miners, dangerous to their long-term health because they are down in a confined space, and as you can imagine, mining is very dusty because they're breaking bits and pieces of rock. So it's really kind of like smoking on your lungs. It's just terrible for them. And a lot of miners end up with black lung disease, which basically either leads to cancer or emphysema in their later years. Also, mining accidents where parts of mines fall in. Now, in the United States, we have very, very strict standards for mining, for clean air in the mines, and we have the technology to keep our miners safe, but accidents still happen, and across the world, in mines, in mining, subsurface mining isn't just coal. They do other minerals subsurface as well, and any mine underground has potential, if it is not constructed correctly, to cave in or to have explosions because of gas buildup underneath. And we're going to see a video that talks about this. Surface mining is huge as far as environmental impact. It degrades the area almost to the point where it can't come back. Most of the mining is done, it's called, surface mining is called strip mining because they strip the earth down. And they can go at least 100 feet deep, if not deeper, with strip mining. The problem with strip mining, again, when you bring the coal out of the ground, you are not just bringing coal out of the ground. Usually in veins of earth that have coal in them, it also has mercury, arsenic, lead. So we're looking at very, very toxic. Arsenic will kill you if you ingest it. Mercury and lead are heavy metals, and there's also sulfur is an issue as well. And that all comes out, it's all integrated with the coal. It's fine underground, it's not doing any damage underground, but once you bring it up and extract the coal from it and leave the heavy metals and the arsenic, you've got a very, very high concentration sitting on top of the ground that has a potential to get into water systems, and certainly in a high concentration sitting on top of the ground, nothing's going to grow in it. So that's what we get down to in overburden. That's the material that it's not used. It's just kind of piled up in a heap and left. So mountaintop removal is the most detrimental in surface mining. And this is, you're going to see this in West Virginia, Tennessee, Kentucky, in areas like that where we have a lot of coal, and they just go in and they start taking the mountains down. And there's no recourse except that these mountains are being sheared off. Well, what happens with this? Well, starts out, they start taking a layer at a time, pulling out the coal, and then you're going to get erosion down the side of the mountain. And that erosion, usually between the mountains where you have a nice valley, that's where the winter snows melt down into, and normally there's a stream down in there somewhere. There's got to be something to carry the water away. So what happens? That fills in with dirt, sediments. So it redirects the stream. Also, remember those heavy metals I was talking about, the sulfur? That gets in the stream and contaminates the stream. Remember that heavy metals are bioaccumulators, and sulfur changes pH. It will cause the stream to become acidic. And I talked a little bit about the impacts of that. So eventually, what they do, they have to get rid of all this overburden, so they just keep filling it in. And you see the bottom picture, and we've lost a mountain. It's kind of sad. Environmentally, the degradation is enormous. Prior to 1977, there were no laws. So mining companies, whether it be coal, copper, tin, whatever, went in, they did their deal, and left the land. Land that would forever be barren because of the heavy metal toxicity, because of arsenic being left over, because of sulfur being there. It contaminated water systems. It contaminated the drinking water of the people who worked the mines. And there was nothing that the government could do. And the really funny part about this is most of those mines were on federal land. So basically the federal government sold the land or leased the land for a little bit of money to these mining companies, and the mining companies sucked everything out of it that was of value, left it in a heap, and then what were we going to do with this? And what were the people who went there to have jobs at the mine? Now they have contaminated water. They don't have a job because the mine's closed up. They have an onslaught of health problems, and we were left as a country trying to figure out how to handle this. So we had to make some laws. And remember that the largest push for environmental law was in the 1970s. So in 1977, we created the Surface Mining Control and Reclamation Act. And this led the way so that mines would have to be reclaimed, that they would have to deal with the toxicity, they would have to put the topography back exactly like it was previous to mining, and that they would have to monitor everything so that we knew that it was going to be taken care of correctly, and that there would not be any contamination. Environmental impacts of burning coal. Different than environmental impacts of producing coal. So let me just overview producing coal. Producing coal. Number one, you go in and you decimate the habitat, especially with surface mining. You're just going to get rid of habitat, whatever's there, whether it's trees, grassland, whatever, it's gone. So first, degradation of habitat. Second, poisoning of habitat. With all the heavy, and primarily we're going to look at, with coal mining, primarily you're going to look at heavy metals. I want you to remember heavy metals, and I want you to remember sulfur. Those things are on top of the ground now. They were covered. They weren't going anywhere. They weren't causing a problem, and the concentration was lessened. By taking the coal out and leaving those behind, the concentration is high. They're sitting on top of the ground. So you have soil contamination. So the soil is not viable to grow anything again. So when they leave the mine, nothing's going to grow because the soil is toxic. So then then the rains come. The rain is going to take the contaminated soil down into some body of water. So you have soil in the body of water. That causes it to be turbid. You're getting heavy metals in there. Again, those are bioaccumulators. And you're also getting sulfur, which changes the pH and causes the water system to be acidic. All of those things hurt the environment. Okay? That's on the ground. Now, environmental impacts of burning coal. This has to do with air pollution. Okay? So, one thing, coal's a carbon compound. It is going to release CO2. In the United States, we have come up with technology to get rid of mercury, sulfur oxides, and nitrogen oxides, and lead, because there is some lead in this. So all of that has been sequestered. Mercury I'm going to talk about in a little bit. It's on the way to being sequestered. Carbon dioxide is not sequestered yet. We've come up with the technology to sequester carbon dioxide. It would require that all the older plants that are creating electricity be retrofitted with this technology, which is very, very expensive. And the coal companies, or the electricity companies, are not wanting to do it. They also, with sequestering the carbon, will have less output per pound of coal, which means their profits will go down. And that's just how it is. So they're against it quite a bit. We have the technology. It's expensive. It is, it does dig into the profitability. And if you want to look at it long term, if we have to use more coal to produce the same amount of energy as we're producing now, that coal is going to run out sooner as well. So you can kind of look at it that way if you want to. Now, what the big two things, sulfur oxides and nitrogen oxides, they're part of acid rain. So when we're putting sulfur and nitrogen into the atmosphere in higher concentrations than those cycles, then they create secondary compounds in the atmosphere because they bond with atmospheric gases and create sulfur, sulfuric acid and nitrogen dioxides and nitric acid. These two, sulfur is the big one with acid rain, but both of them are part of acid rain. So when it rains, then we get that sulfur coming down into the ecosystems. It causes damage to vegetation, and also then it's running into the water systems, changing the pH. So can also cause, as far as you economically, it's not going to hurt you if you're out in acid rain. It's not going to burn holes in your skin or anything. But it will cause the paint on your car not to last as long. It hits historic statues. Some of them across the world have been kind of eaten up by it. It also causes you to have to paint your house more, or business, that kind of thing. Mercury and lead. Lead's already been taken out of it, and mercury should be mitigated by 2016. The law is new, but those again are heavy metals, and they cause neurologic problems and birth defects. So how do we make coal clear? Well, for many, many years, the United States has required all of this to be done to coal to make it cleaner. Scrubbers actually take out the sulfur. Basically what it is, a scrubber is a big pipe that is fitted in and it's got water in it. So as the coal is heated up and burned to create energy, that heat creates energy, there's exhaust, ash that comes out. And the scrubbers, that the exhaust is pushed up through the water, and the water actually bonds, because water is polar, it bonds to the sulfur, and it will pull out most of the sulfur and particulates. Another thing that's used to get out really fine particulates is electrostatic precipitators. Basically, these act just like static electricity and grab hold of particulate matter. And so those two things have been used for years in the United States to clean up coal. Lime neutralizes acid, so it will neutralize the sulfur. If the sulfur content is extremely high, they'll add lime before it goes through the scrubber. They'll still have a scrubber as well. Then what do? You've got this dirty water, highly acidic, and you've got the sludge from the electrostatic precipitators. Well, what can you do with it? Well, you can make drywall, for one, and fly ash, which is used to make concrete. So those are things that can be done with it to keep it out of the environment. So, Clean Air Act. Clean Air Act has had several updates. The Clean Air Acts, there was a Clean Air Act before 1970, but it really had no teeth in it. So this is when we say the Clean Air Act was enacted, 1970. And then in the 1990s, required power plants to reduce SOx and NOx emissions, and that's sulfur and nitrogen emissions. Current lawsuit force EPA to regulate CO2, and again, I talked about that previously. Clean Air Act is one of the laws that you're going to need to know for the exam, and know that 1970 was when it was enacted. 1990 put some teeth into it to reduce SOx emissions. Our last slide, I think. No, it's not. We've got one more. Okay. Fluidized bed combustion. This is a clean way to do coal. Basically, you take the big rocks of coal and you smush it into little teeny pieces, and you mix it with limestone before it gets heated. The coal travels down through here and gets hot. What this does, the heat from the coal and the exhaust from the coal goes through this area. This collects the dust. Okay, so all the particulate matter drops down through here, and kind of like a electrostatic precipitator. And then this is your flue gas coming out here. Basically, the steam coming through here, this is going to be steam because it was water to begin with, and the steam coming through here then will go and create energy, and I'll talk about how a turbine turns in class, so you can understand that a little better. So this process eliminates, basically when you put the limestone in, you're neutralizing the acid in here or the sulfur in here, and so it's neutralized here, so therefore you just have to have a dust collector coming on. I'm going to plug in my computer. Okay. The last slide here for part 2. Mercury emissions, finalization from EPA came down, this was 2011, and full implementation of the law 2016. Basically, whenever a law is amended or it becomes more stringent or it is enacted, companies have wiggle room and a time frame with which to comply. And you can't expect a company just overnight, okay, we made the law today, tomorrow you better be in compliance. We have a little bit more heart and allow them a time frame which to get tooled up. And so all plants need to be tooled up by 2016 to decrease the mercury emissions. And basically, mercury that is pulled out of the ground, when it's heated up, it turns into a different form called methyl, and the methyl mercury is what bioaccumulates. And so that gets in the food chain, gets in the water, gets in the fish, and voila, you can't eat fish, because then that's going to get in you. So you can't eat very much fish. So anywhere around coal plants, they're seeing a high level of mercury in people, a higher level than in areas with no coal plants. Also in the food chain. So they're trying to get that down. And this is the hazard, nervous system disruption, including mental retardation. So that is it for part 2. Tune in for part 3.